dots on either end, and then your concave down in between those. So from 0 to pi, 2 pi to 3 pi, 4 pi to 5 pi, dots on either end, because that's going to continue over and over again. Um, 7, sine is an odd function. An odd function has 180-degree rotational symmetry. If you can rotate it 180 degrees and it ends up where it was before, then it is an odd function for that. Any questions on those first 7 about sine? 8 and 9 ask you what would all these answers be if we switched it to cosine. So 1, 2, 3, and 4 are all going to be the same. You'll get the same answer for cosine for those. There was a little question I heard over frequency. Frequency is just the reciprocal of period. It's just period flipped. So it is also going to be the same because if period's the same, frequency has to be the same for that. The ones that are going to be different are going to be 5, 6, and 7. 7's the easiest one to fix. Cosine is an even function there. And let me look at this alongside the graph for cosine. An even function is on the notes, but it can be folded along the y-axis and it matches up. It's got y-axis symmetry, and cosine has that, so it would be an even function there. For your concavity, the concavity is going to switch at your increments of pi over 2. So for concave up, I started at pi over 2 right here to go to 3 pi over 2. That's my first section of concave up right there. And then 5 pi over 2 to 7 pi over 2, and then that would continue on for that. And then for 6, it's the in-between for that. So negative pi over 2 to pi over 2, your concave down, and then 3 pi over 2 to 5 pi over 2, and that continues on as well for that. The graph of cosine is just sine slid over to the left pi over 2. So you kind of can see where you had pi to 2 pi. If you just subtracted pi over 2 from both of those, this is what you would get right there for your concavity. Okay. Questions on anything from those? If you need to look back at anything, we now have a set of notes here that include everything. I looked through it. It looks pretty good here. I like this picture that that you guys put up here for your period and frequency, because that frequency we don't do in Math 3. So that one might be something new that you're not quite sure about, or we don't usually. I don't know if Mrs. Martin and Coach Wood did. But the period of this graph is how long it takes to repeat. So this graph is repeating every 1/4. The x-axis, from maximum to maximum, that's a difference of 1/4. The frequency is the number of waves that you have in one time period, whatever that might be. So in this case, if your period is 1/4, that means you've got 4 full cycles in that first hour or second or whatever that's talking about. One thing you can think of that you may know about that is given in a frequency is on your car, you have your tachometer, and it's read in RPMs. What does that stand for? Rotations per minute. That is similar to, that is a frequency. So your car is, and I think it's in thousands. So your motor is going through a full cycle, 3,000 times in a minute whenever you're running at 3. Your RPMs is at 3 there. So, so that's a frequency. That would be, like if we graph that, if we graph like where the piston was at in the motor, it would have 3,000 little cycles in that first minute there. So,